If you care about how people survived, built and passed knowledge forward long before modern materials, then this channel is for you. Subscribe now to Legacy of Survival and share this episode with anyone who still believes medieval builders were guessing their way through history. What you're about to hear is not folklore, not romantic myth, but a largely forgotten mechanical process that quietly shaped the endurance of Europe's strongest wooden structures. For the next minute, stay with me closely. Most people assume medieval buildings lasted because of thick timbers or divine luck. That assumption collapses the moment you look at surviving beams pulled from cathedrals, bridges and granaries that have endured 6 to 8 centuries of load, moisture and vibration. These timbers were not merely cut and assembled. They were mechanically transformed before ever being raised. The key was pressure, sustained and controlled, applied through large wooden presses that altered the internal structure of the wood itself. So this is the story of the forgotten wood press. You know, a technology that made medieval buildings surprisingly resilient, really, and that still holds some practical lessons for anyone who's serious about long-term durability today. Why medieval builders distrusted raw timber? Well, that explains everything that follows. See, freshly cut wood is unstable. It twists, it shrinks, it cracks, and honestly, it weakens as moisture leaves the fibres. Medieval builders, they knew all this through failure, and let's be honest, failure was expensive. When a roof sagged or a bridge warped, entire communities, they paid the price. By the high Middle Ages, master carpenters had learned that, well, seasoning alone was not enough. Timber had to be forced into submission, its fibres compacted and disciplined before construction even began. The forgotten wood press was not a single device, but actually a class of heavy compression systems built almost entirely from oak. These presses evolved from ancient screw and wedge technologies inherited from the Roman world, particularly those large agricultural presses used for olives, wine, and linen. The principle was simple, but powerful sustained pressure over time permanently altered the internal geometry of wood fibres. Under compression, cellulose fibres collapsed into tighter alignment, reducing voids where moisture could later re-enter. The result was timber that moved less, resisted rot longer, and bore weight more predictably. In medieval building yards, beams destined for roofs, towers and bridges were often pressed after partial seasoning. The wood was stacked within massive frames, pressure applied using screw mechanisms or weighted levers, and left under load for weeks or months. This was not hurried work. Builders understood that time under pressure mattered as much as force. When released, the beam retained much of its compressed density, becoming harder, heavier, and far more stable than untreated timber. This process explains why timber roofs in structures like Notre Dame de Paris survived centuries of wind load without modern fasteners. The famous Forest of Notre Dame was not only a triumph of carpentry design, but of material preparation. Pressed beams resisted creep, the slow deformation that causes roofs to sag over generations. Compression also served as a biological defense. Fungi and insects, you see, thrive in wood with accessible air pockets and fluctuating moisture. Pressed timber denied them both. By collapsing internal spaces, builders reduced oxygen flow and limited moisture retention. This mechanical protection worked alongside surface treatments like tar, lime wash and smoke curing, but really the press addressed the problem at its core. What makes this knowledge especially valuable is how transferable it remains. If you are a survivalist, traditional builder, or off-grid homesteader working with timber today, the medieval approach offers a clear alternative to chemical treatments. These days, you can actually apply controlled compression using modern clamps, screw jacks, or even weighted frames. The process starts with partially seasoned wood, and then you apply steady pressure along the grain, keeping it up for quite a long period. Historical records from guild regulations, interestingly enough, suggest that pressed beams were really reserved for high-stress elements. Things like roof trusses, bridge decks, mill frames, and defensive structures. Ordinary walls, well, they just used ordinary timber. This kind of selective application shows us that medieval builders weren't blindly traditional, but actually quite strategically efficient. The decline of the wood press, well, it came rather quietly. As sawmills industrialized and iron fasteners improved, speed began to replace patience. Builders started to rely on redundancy rather than actual material transformation. Then chemical preservatives, in the 19th and 20th centuries, finished the job, pushing mechanical wood treatment right into obscurity. Yet, modern failures, from warped framing to chemically treated wood rotting from the inside out, really reveal what was lost. Understanding the forgotten wood press, well, it changes how we interpret medieval architecture. These structures did not survive despite technological limits. They survived because of precise, experience-driven engineering rooted in material science long before the term even existed. Medieval builders listened to wood, tested it, forced it to behave, and respected its limits. If this kind of buried knowledge matters to you, if you believe survival is about understanding systems rather than just buying products, then this channel exists for you. Subscribe to Legacy of Survival, share this episode with fellow historians and builders, and, keep these hard-earned lessons alive. The past still has work to do if we are willing to learn from it.